Aquaba to the math classroom. We are looking at the part 2 of the fundamental theorem of calculus. And the part 2 says that, the part 2, if you have not seen the video yet on part 1, you'll find the link in the description. It says if I have a function, let's say g of x, on the interval a to b, satisfies g prime, the derivative of x, to be equal to f of x. So if this satisfies this, then the integral, the integral from a to b of what f of t is dt is going to be g of b minus what g of what a. So let's take an example here. So example, is, let's say I have the function so let me give the integral. So we have the integral from -2 to 1, and the function is what s cubed dx. We want to evaluate this using the definition above. So you realize that with this, our s cubed here is continuous on the interval. What is the interval? From -2 to 1, -2 to 1. So now the antiderivative. So we first find the antiderivative of f of x, which is this. F of x is going to be what? 1 over 4 x to the power was 4. Okay, so the part 2, what does the part 2 imply? The part 2, it means that I have my integral from -2 to 1 s cubed dx is going to be g of what? 1 minus what? G of what? 2. And this is going to be equal to 1 divided by 4, 1 to the power 4, minus 1 divided by 4, minus 2 to the power 4. If you simplify this, this is going to give us minus what? 15 divided by what? Minus 15 divided by 4. So don't forget what it means here. Okay, so if you have the integral, what do? You find the antiderivative of your function, then you substitute what? Your boundaries as well. Okay, then let's look at another definition. Because I mentioned antiderivative, what does it mean? If I say antiderivative, so a function it's called an antiderivative of f, let's say of our function f of x, which was equal to this. If one has, so this implies that my f, the derivative of f of x is going to be equal to f of what? X. That is what it implies. So example, so you realize that 1 over 2 x squared is the antiderivative of the function f of x equal to what? X. Because if I find the antiderivative of this function, the integral of this function, this is what I get, 1 over 2 x squared. So there are many examples to look at as well. So let's take another example. I have there. So another example is I have the integral. So let's say find the area. Find the area under the parabola y to be equal to what? X squared from 0 to 1. Alright, so we know how to find the area under a parabola. So for a parabola, we are looking at a curve and we want to find the area of that. So from here, we know that the antiderivative of the function, this is the function. The function is f of x, it's equal to what? X squared. So the antiderivative is going to be what? F of x, which is going to be 1 over 3 x what? Cube. So that if I want to find the area using the fundamental theorem of calculus from what? 0 to 1 of what? X squared dx, it's going to be what? 1 over 3 x what? Cube. The interval is from 0 to 1. So this is equal to 1 over 3, 1 minus, so from our definition, 1 over 3, 0. And this gives us what? 0. So we have what? 1 over 3. Applying what? The fundamental theorem of what? Calculus.